Hello, learners. Welcome back to Wizartist. Today, we are going to be studying Class 8 Physics, Chapter Sound. What is sound? You must easily recognize that a period in your school is over whenever the school bell rings. When you hear the sound of knocking, you understand that someone is at your door. When someone is approaching you, that is, coming near you, you recognize that through the sound of their footsteps. In your school's music room, you must have observed many different musical instruments like the flute, tabla, and harmonium, which produce a melodious music. That exactly is sound. Sound plays a very important role in our lives. It helps us communicate with one another. Different sounds that we hear through our ears helps us understand what's going on around us and gives us a better understanding of our environment. In this chapter, we will answer a few questions like how is sound produced? How does it travel from one place to another? How do we hear sounds? That is, how do our human ears work? Why are some sounds louder than others? Etc. Coming on to the first question, how is sound produced? In simple words, we say that sound is produced by the to and fro motion, that is, vibration of particles in the medium where the sound is traveling. Here, there are many particles. Now, this is a very magnified or zoomed view. In reality, these particles are very microscopic and not easily visible. As you can see here, that when there is production of sound, these particles basically move ahead and back, ahead and back, ahead and back. This motion is called oscillatory motion. And in other words, we can say it is the vibration of particles. So this to and fro motion that we just observed, like this, is exactly oscillatory motion or vibration of particles, which produces sound and helps it to travel from where it has begun to being heard by us. Let's look at this example. Take a metal plate and hit it with a stick. You can hear that some sound is produced. Then, when you touch this plate, you can feel vibrations. Thus, we can say that whenever anything vibrates, it produces sound, or vice versa. That is, when sound is produced, there is always some kind of vibration. Sound is also produced by various instruments. For example, cymbals. When cymbals hit each other, the player can feel the vibrations, and everyone else around, including the player, can hear its sound. Ghattam is an earthen pot-like instrument traditional to India which also works on the same principle. Whenever you are playing a drum, you can notice that the top skin of the drum moves up and down. This means that the upper skin, that is this part which is being played, is the skin, and when the upper skin is vibrating, there is vibrations, and vibrations produces sound. Another example is that of guitar over here. Here I have a guitar with me, and whenever I pluck a string of the guitar, you can hear some sound. You can notice that string vibrates from its original position ahead, behind, again and again. A thick string and a thin string produce different sounds because they vibrate differently. Humans also produce sound. I'm talking to you and you can hear me. Therefore, my voice is a sound that I am producing. How do humans produce sound? Try feeling your throat. You can find a heart bump that moves when you swallow or speak. This hard bump is present at the upper end of the windpipe and is called the larynx or voice box of humans. This organ is responsible for all sound production that we do by speaking. From a top view of the larynx, you can notice that it has a structure like this, wherein in the middle there are two string-like structures called vocal cords stretched across. So these string-like structures are vocal cords, and suppose if this is the top view of the larynx, these vocal cords are wrapped around like strings, similar to how you wrap a rubber around a paper cup. It leaves a narrow slit in between so that air or wind can pass through the lungs. Now, when the lungs, in a controlled manner, force air through these slits, the vocal cords open and close, that is, vibrate. And thus, these vibration, which causes the production of our voices. Very thickness and lengths of these vocal cords affect the quality of voices in different human beings, which is why some people have a very low pitched voice, like an old man, and some have very high pitched voice, like a young girl. We will understand and learn what pitch means in terms of sound ahead. Now let's understand the medium for sound, that is, through what does the sound travel? We know that sound is produced through vibrations of particles present in the medium where it's traveling. So, medium is basically the matter, that is, state of matter, solid, liquid, or gas, through which sound is moving. Solid, liquid, and gas all have particles inside. These particles are tightly packed in solids, as you can see here, a bit loose in liquids, and very loosely in gases. But nevertheless, all of these have particles, and because there are particles present, sound can travel through them through the vibrations of these particles. On the other hand, let's take a vacuum. You can see vacuum here is represented by an empty box. This is because vacuum does not have any particles. It is void of any particles. And because there are no particles, no vibrations can take place. And thus, sound cannot travel. This is the reason why sound does not travel through space, which is basically a vacuum. So, we can conclude that sound needs a medium to travel, a medium which has particles in it, and these particles must vibrate for the sound to move. How do we hear sounds? We hear sounds through our ear. The ear is responsible for collecting all the vibrations in sounds from the surrounding and convert it into messages that can be interpreted by the brain. Once the sound is interpreted by the brain, we understand it better. Let's understand the functioning of the human ear. This is how the human ear looks from inside. The outer part, which is visible to us, is called the outer ear, and it has a funnel-like shape. This funnel-like shape helps in the efficient capture of the sound around us. The sound, once captured by the funnel-shaped outer ear, travels through the ear canal, which is the passage in the middle, and goes to the eardrum. When the eardrum receives these vibrations from the sound, it starts to vibrate. This helps increase the vibrations. These vibrations then are amplified, and in their amplified form move towards the shell-shaped structure in the inner ear called the cochlea shell. It converts these vibrations to messages that can be transmitted to the brain via the audio nerve. These messages are then interpreted by the brain, and we understand the sound better. Describing sound. Different sounds have different qualities, and this is because of the differences in these factors that control the properties of sound. The first one is oscillations, which is the movement of any particle to and fro. That means the particle moves ahead of its mean or original position, moves behind, and eventually comes back to where it started from, as you can see over here. This movement continues as long as the sound is traveling. Here is a definition of oscillations. Then we have frequency, which is how many of these oscillations take place in unit time, that is, in 1 second. How many times does the particle move to and fro in 1 second? The SI unit, or the standard unit of frequency, is Hertz, represented by the letters Hz. In formulas, frequency is represented by the Greek letter nu, which looks something like this, or some people write it like this, which looks like the Roman V. Then we have pitch, which is related to frequency. If the frequency of any sound is high, we describe it as shrill or high pitched, just like the voice of a young girl or a baby crying. When the frequency is low, the voice is also low pitched, like the brood voice of an old man. Next, we have amplitude and loudness, which both are related. Amplitude or loudness can simply be understood as the volume of sound. That is, how loud is the sound. If amplitude is large, then the sound is also very loud. That means the volume is high. And if the amplitude is small, then the sound is feeble, which can be understood as volume being low, just like how we adjust the volume of television or any other device. Lastly, we have time period. Let's understand this concept with the movement of the particle. Time period is the time taken by the particle to complete one cycle of vibrations. That means how much time does the particle take to move ahead and back and then come back to its original position. Time period is inverse or reciprocal of frequency. That is, frequency is equals to 1 upon time period, or time period equals to 1 upon frequency. These concepts are very important, especially to understand sound in your further classes. Now let's understand the different types of sound. The first one is audible sound. The human ear cannot hear all sounds. Humans can only hear sounds in the frequency range of 20 to 20,000 hertz. These sounds are called audible because it is the sound that we can hear. What if the sound is below 20 hertz or above 20,000 hertz? Such sounds cannot be detected or heard by our ears, and therefore it's called inaudible sound. Sounds below 20 hertz are called infrasonic, and above 20,000 hertz are called ultrasonic. You must have heard the unnecessary honking on traffic jammed road or the construction work going around you. These kind of sounds are unpleasant, and you do not like to hear them. These are called noise. On contrast, music is pleasing sound that you like to hear. It is produced by different musical instruments like guitar, piano, etc., or a good singer. Coming on to noise pollution. Noise pollution means presence of excessive or unwanted sounds in the environment. These excessive and unwanted sounds is what is called noise, like we just learned. And if this noise is present in a large amount in any environment, it is not good for us. And this exactly is called noise pollution. What causes noise pollution? Noise pollution is caused by vehicles, especially due to their unnecessary honking. Fireworks, crackers, or explosions are also very loud and contribute. Machinery like the ones used for construction and loudspeakers add to these noise. In our homes, loud volume televisions, old and unchecked kitchen appliances, and damaged AC also generate a lot of noise. any type of pollution is harmful, noise pollution also has its fair share of harms. Noise pollution causes a lot of health issues. Any person living in an environment full of noise pollution can face loss of sleep, that is insomnia, high blood pressure, that is hypertension, anxiety. It can also cause hearing impairment, for which they might have to use hearing aids to be able to hear properly. Such impairment is usually caused because the eardrum is damaged. Now, it's not that the person living in a noise polluted environment will surely get these problems, but they are more prone or they have a higher chance of facing these health issues compared to a person living in a less noise pollution or no noise pollution environment. How can we reduce this noise pollution? Because it does cause a lot of problems. We can install silencers in aircraft engines, vehicles, machines, and appliances. The silencer basically helps reduce the noise that is produced by these kind of machineries. Now, we learned in the chapter friction that friction is mainly responsible for such noises. Keep noisy industries away from residential area. If any industry makes a lot of noise, it is better to situate it away from where most people live. If such noisy industries are set up in residential area, it can increase noise pollution and pose a threat to the living population. Residential area basically means the area where homes of a lot of people are situated. Limit honking and unnecessary use of vehicle horns. There are a lot of times where we don't really need to use horn and yet we still use it. It's a major problem, especially in our country. And it also has a lot of harms, especially by increasing noise pollution. Lower TV or music volume to avoid disturbances. Whenever you are watching TV, ensure that the volume is enough, just that it stays only in your house and it does not escape to your neighbors. Conduct loud activities away from homes, especially during festivities. We use a lot of loudspeakers to celebrate the festival, and most of the times it is located near our residence. But this is not good. Whenever we want to conduct any activity of such sorts, we should conduct it away from homes so that people who are busy with other work or are trying to peacefully live in their houses are not disturbed. The last one is the solution to almost every pollution problem on Earth. That is, planting trees. Planting trees help absorb the noise, and when noise is absorbed, of course, the pollution is also reduced. So let's ensure that we try to follow any or all of these methods which are viable to us to help reduce noise pollution. And this was the last topic of this chapter. Thank you for watching this video. I hope you learned a lot from this. If you did, don't forget to like, share, and subscribe. Thanks again. Bye bye.